Now let's understand Bohr's correspondence principle. Now this Bohr's correspondence principle connects classical theory and quantum theory. And in a layman's way, this principle states that in limiting situations, the result from classical theory as well as from quantum theory must agree. So let's go into the derivation of Bohr's correspondence principle as applied to atomic model. I repeat again, Bohr's correspondence principle connects quantum theory and classical theory, and according to it, it says that in limiting situation, the result from two theory, that is from classical theory and from quantum theory, it must agree. Now, to put it in a more refined fashion, the Bohr's correspondence principle can be stated that the dynamics of a system as described by quantum theory must agree with the classical description of that system in the limit of very large quantum numbers. The classical frequency of radiation emitted by a system such as hydrogen atom is same as that of frequency of orbital motion of electron according to classical electrodynamics. Now, we are trying to calculate the frequency, one from quantum approach and other from classical approach. So the classical approach says that, which we are referring it as the classical frequency. The classical frequency of radiation emitted by a system such as the hydrogen atom is same as the frequency of orbital motion of electron according to the classical electrodynamics. Now we know that mRn square omega will be equal to nh upon 2 pi. Now this equation is nothing but law of quantization of angular momentum, which is one of the postulates in Bohr's atomic model. Also we know that frequency is equal to omega over 2 pi. So when we make substitution, we get the expression for frequency, and the value of f is nh upon 4 pi square mRn square. We know the value of Rn, that is the Bohr radius when electron is in nth orbit. So when we make substitution for Rn, we get the expression for F classical, that is the frequency of radiation as calculated by classical electrodynamics, is equal to m e to the power 4 divided by 4 epsilon naught square h square n cube, and which is equal to twice E naught divided by NH cube, and the value of E naught is 13.6 electron volt. Now let's make calculation for frequency of radiation emitted using the quantum approach. Now let's consider transition between two successive energy levels. The frequency of radiation is given by, that is, HF is equal to En minus E in subscript n minus 1. Using the expression for energy of electron in nth orbit, we get minus E naught divided by n square, and minus minus becomes plus E naught divided by n minus 1 whole square. So we get the expression for frequency, and that will be F is equal to E naught divided by H in square bracket. Numerator we have n square minus in bracket n minus 1 whole square divided by, that is denominator, n square into bracket n minus 1 whole square, which on simplification gives us F is equal to E naught by H, numerator we have 2n minus 1 divided by n square multiplied by in bracket n minus 1 whole square. When the value of n is very large, that is, let's say n is approaching infinity, the value of F, that is frequency as obtained from this quantum principle, we get approximately 2 E naught divided by n cube H. Now we can compare the two results. Earlier we have obtained the frequency of radiation using classical approach, and this time from the quantum theory they are the same. That is precisely what we call it Bohr's correspondence principle. I repeat again, this principle connects classical theory and quantum theory, and this principle says that in limiting situations for large values of principal quantum number, the result from classical theory and from quantum theory must agree. We have just proved in one case where we calculated frequency of radiation as predicted by classical electrodynamics and frequency of radiation as predicted by quantum theory. These two values are found to be equal. Now, there is something very interesting to note, that the correspondence principle immediately suggests a generalization of Bohr model. How? Let's understand it. We know that spectral lines emitted by an excited hydrogen atom correspond to transition for which delta n is equal to n initial minus n final greater than or equal to 1. There should be no reason why for large n the quantum jumps must be limited to delta n is equal to 1. However, if we do allow other changes in n such as delta n is equal to 2 or 3, the frequency of emitted radiation will be integral multiples of fundamental frequency which we have calculated earlier. Classically, however, a charge in circular orbit radiates only at rotational frequency. This discrepancy between the classical and quantum model in the correspondence limit is removed if elliptical as well as circular orbits are allowed. The extension of Bohr model to include elliptical orbit was carried out by Sommerfeld, who demonstrated that one could thereby account for the so-called fine structure of spectral lines. Now this section I have just specified for the interested readers. Sommerfeld atomic model is not part of IIT JEE syllabus or any other engineering entrance exam. So here the discrepancy between classical result and the quantum theory result can be accounted if we consider orbits to be elliptical. Further, one of the limitations of Bohr atomic model was that it could not explain the hyperfine structure of spectral lines. Now, using the correction that electrons are permitted to move in elliptical orbit, we could account this discrepancy. Also, we could explain the hyperfine structure of spectral lines.